Okay, first, what are we going to do? I was planning to make a workshop with puzzles, a lot of the different kind of puzzles that I've done. But Turkish Airlines lost my bag with my 20 kilos puzzles. So, so I have to do something else. It's plan B, a kind of improvisation, but what we are going to do is to learn the basis of the way to draw patterns just freehand on paper, on the, how do you call it? What kind of paper? The grid paper. What kind of paper? And yes. Okay. But also, I have prepared for you paper like this. It's a triangular paper. I will just show you how you can use it, but we are not going to work very much with that. But you have some sheet of paper for you that you can use after the conference anywhere, and you can photocopy because it's you will see it's very useful. So now take maybe three for each one, for each person. Three for each. Yes. Yes. Yeah? Yes. Now I was because we are waiting for the paper. First, I want to present you some of the puzzles that are not here, the lost and puzzles. The first one, I did it a long time ago. It was for the Institut du Monde Arabe, Institute of Arabic World in Paris, because they have animation for schools, and they didn't have anything for geometry. And so it was an opportunity for me to realize, to make in real an idea that I have had in mind. So that's why it's a kind of puzzle. That's a component of the puzzle, and the number of each tiles. This is just for framing. You will see. That's the tiles. That very standard tiles in the octagonal family. Okay, how does it work? It works first the framing. So you have tiles that can fit together, and they make a big frame. The interesting thing is that this can be put like this on the small bag, and but you can add some tiles here, so you have a space more smaller. So because it depends of how many times we have to do things, and we can start with this situation or this one, but this one is too small. So that can be a good starting point of this one. With that, what I need, and after we put the tiles inside, and because the framing is a help to do something very quickly. And now what I have to explain some rules, because something are prohibited, maybe, yes. Okay, you see here, we have two issues. Here, you see that this line is dying. That line died. So the first thing is that the line must not die. And when you draw it, it's the same. The line, you see, dying. No, very bad. The line have to continue. for this one is the same. That's the first word. And yes, okay. You see, line is giant. It's very bad. Now, so you see, it's very easy to solve that problem. Okay. Now here we have some issue. This, you say, oh, it's we have we alternate the color. It's okay. But here, it's not so good. It can be sometimes, but take care. Because, you see, that line is happy. But that line is not so happy because the line is forced to change the direction. The line can change the direction only when she freely decides to do it. But the line don't like to be forced like that. If you see the one line is happy, but this one is very, very unhappy. So take care. So what if you want to solve this situation, there is always a solution. For example, here we can have this, but in the puzzle I did, that tile doesn't exist, but never mind, I can do it with small tiles I have. So that's all. That's the sample words. Then, starting from the small frame, I can do that. Starting from this one, the point is that when you are playing with that, even if you don't know anything about Islamic geometric design, about the leaf, just playing with the tiles, you got this pattern, which is a very standard pattern. It's not quasi-periodic pattern. It's just a pattern, and because it's a very simplest solution, so everybody can got it. Or starting with this one. Just playing, people goes to that solution, which is one of the simplest solution, or this one, which is ever more simple too. And with, if we have time enough, we can go to bigger examples. So, and also I have, oh, good, thank you very much. And also I have a small frame. And with this one, what we can do things like that are very simple. Here you can see that one line is forced, but this is just a variation here. It's not, we can do it sometimes. But this one, you see, it's not standard. It's very special because we have rotation, so, and that kind of things. Now the thing is cut by laser, and for example, and it works with kids, and it works with academics. It works with everybody. For example, look at this little girl. What she did? She was working with a small frame. Then she goes to that composition, why not? And then I suggest her to break the symmetry. Okay, like that, and then like that, and finally she got this pattern with that kind. You see that nice shapes in nice stars in shape of butterfly, like that, and. Yes. So at the beginning, I was preparing some samples, some examples, but I did it just once because after it was clear that we don't need to have an example to reproduce, but people can redo the patterns by their own. Okay. Now, Another, what kind of pattern can I show you? Just one moment. No. Yes, there is a pattern, puzzle I did for the Palais de la Découverte. It was just tiles like that. It was a demonstration. You play with it, and it's a demonstration of a lot of relationship between octagonal pattern and quasi-crystal and self-similarity. But we don't. With that kind of tiles, with that is up and bottom, the double size, so we can go to things like that, and this, etc., etc. And this was a prototype for another version, so we can use a mirror, and so you are working, looking at that, and when you are working, another pattern is growing on the other side. And the other pattern is kind of quasi-crystal, octagonal quasi-crystal. And finally we did it, and it's like that. But it's it's in my lost baggage. I'm sorry. So we have okay. I could talk about the other puzzle, but better now to start working. So we have a paper. The best. No, that's not the best. Never mind. That's not the best. Bon. So you can maybe take 3 or 4. Maybe if we have enough, try 4 for each one. The problem is that it's not. Now, about this one, the triangular one. So I'm just showing the way you can use it. But okay. For example, you can use this for any triangle, not any, but a lot of triangular pattern can be drawn following this triangular grid. For example, that one, or this is Alhambra, or so you can use it for this pattern. Of course, here I have the dissection of the pattern. We have this is a kind of exercise. This was in my first book. The exercise is to mix patterns that can come out this triangular grid. And here, if you don't have a paper with triangular grid, you can make it using this approximation. So if you start from here, then 4 square to the right, then 7 square to the left, you go this point, and this angle is very, very, very near to 60 degrees. So you have just an error of 1%. So it's very good. You can do that. You can always manage drawing by hand. So here are some examples. All these patterns come from can be drawn on that grid. Here it's from the book of Bourgoin, and you see the underlined grid, etc., etc. You have a lot. Yes, this is very nice, etc. This from Topkapi scroll, and you can see the underlined grid, etc. So So you have now you have grid, and you can use it at home. You can photocopy it. It's very powerful. Now we are starting. Momentito. Where is my thing? Okay. Never mind. Okay. Now we are starting with drawing that kind of things. Well, first we start with just exercises. It's like solfège. You know solfège? I don't know the word in English. When you learn music, so just have to do something. I need. Can I have another one? Another chair? Another chair like that? A chair. Can I have the same chair, please? Waiting. Because I want to show you, so I have to make projection of.
Not sure if that's going to work.
Yeah. I'm sure it can work. Isn't it perfect? Never. Not here. Never mind. Yes, okay. I know. Never mind. Just no. That's just an example. No. Don't mind about my drawing. First, you have to learn to draw lines. The black one, the black one.
I think it's on your table.
I can see. Yes. Okay, thanks. So, first, you see the squares. First, try to draw lines going like this on the diagonal. Line passing by every vertex. Draw some lines like this. That's very simple. So you can do that, and I am going to find my so sorry if it's workshop. It's a kind of improvisation. So exercise. You have to do that kind of lines. You can see maybe it's very easy for you. Okay. You also have to do it in the opposite way. Take care to follow. Just have to follow the grid. It's very easy. No. Now, what is easy? It's just to follow the line, like that. This is easy. Now, something that is less easy is to follow the line in the horizontal and vertical direction, but passing by the middle. Okay? Vertical and horizontal. Just free hand, no strand head. Just free hand. Huh? The middle, passing by the middle. It's easy to maybe. You don't have to be so much precise. If the line is dancing let the line dance, no problem. Okay. 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 Now, the thing more difficult. Take care, because it's not so easy. It looks easy, but it's not so easy. You are drawing line like this one, diagonal line, but passing by the middle of the edges. For the line never pass by a vertex. Just, can you see what I draw? What I'm drawing? I'm drawing something just to help me. So the line is like that. Never passing by. Never passing by a vertex. Can you see on the board? Oh, yes. I can make it bigger if you want. So, okay, I make it bigger, a little bit bigger. So, is it better like that? So, you see, the line passing by the middle. Because the vertex are very attractive. So what you are going to do maybe is you start very well and then you are going to the vertex. So take care. So you have to draw some lines like this, and of course after in the other direction. And that. Okay, that's a kind of solfège. Why?
Small
No,
piece and small
look.
piece.
No. Look at. From here, never touch a vertex, but here. See, it's online. It's just for 45 degrees compared to the grid. Okay. Okay, it's clear. Yeah. Good. Yes. Yes, perfect. So, you are pretty good. We can go ahead. Now, we are learning the way to draw the main tiles. So, you have two main tiles. The first is an octagonal star, and the second is a tile we call the shaft. You will see. First, the way to draw the octagonal star. For example, in the simplest way, this is. No, it doesn't work anymore. So, this star is made from two squares. One square here. The second, rotation of 45 degrees. So what I do is just a fast approximation. I take here more or less the middle here, and I draw the square like that, just by hand. So finally, what I have to draw is something like that. Here, at the middle, vertex, vertex, middle, vertex, middle, vertex, middle, vertex, enfin, etc., etc. Okay? Ah, thank you. So you will say, this star is very ugly, it's not very nice, because it's not an exact construction. It's not, it's just an approximation. In terms of number, when doing that, it's like saying that a square of 2 is 1.5, which is not a good approximation. But never mind. Never mind. Absolutely never mind. So, okay, so now when you do that, it's very easy. What is less easy if the center is not on a cross point? Maybe if the center is here, you have to draw it like that. Half, half, etc. Is it clear what I'm doing? And here to the vertex, to the middle, to the vertex, to the middle, etc. That's first situation. Second situation. Third situation, more difficult, when the center is here, at the center of a square. So, the initial square is here. So, puff, puff. Translators, can you translate when I say puff, puff? Thank you. Yes. So now exercise, it's another exercise. Draw some of them like that until you feel easy with that. Thank you. Okay, now the second shape you need. Okay, the second shape is made of two squares. Everybody is ready? Look at. Oh, everybody look at. The second shape made from two squares. For example, if I start here, like that. Is this a square? Is it? Yes, it is. Okay. So another one now. Like that. Okay. And what is the second shape? Second shape that we call soft is the shape we got when we mixed the two squares. Okay? But now, it's not ask for your attention 1 minute more. Let's look at. Now from here, I can draw another star. So the center is here. Now, look at. From one center to the other center, how many square?
7.
Yes, 7. Remember 7. So first draw this, please. Going to go to that direction, to the diagonal direction. So look, if I want to have the same but turn of 45 degrees, look what I have to do. Have to do the same activity. This, you know, it's like 2 square. So I'm going to that direction. I have to have 1 square here, or 1 square like that. Okay, one another square like that. Is it clear or not? Yeah? Talk? Does everybody can see the square? So then I am here and I can draw another star there. Okay, with the center here. And where is the 5? But you see that from here to there, you have how many square?
5.
Yes, 5, exactly. So we are dealing with 7 and with 5. You can remark. You see, if 7 by 5 is it's like this, is 1.4. And look, it's strange because I was starting with a bad approximation of root of 2 here. When I draw that, it's like if I said square of 2 is more or less 1.5. Now, drawing this is like saying that square of 2 is more or less 1.4, which is better. So when your drawing is growing, the approximation is getting better and better. That's a funny thing. So now, okay, please draw that in that direction and you rely the lines. Okay? Is it clear? Clear? No, any question? Because these are the basis. If you know the basis, after you can do anything you like. And the basis is quite simple. Okay, now, please everybody, have a look. Because here, we have the simplest skeleton possible. So it's a very good example. Now, when I have a skeleton, a closed line made with star and shaft, what I have to do is to fill inside. Why to fill inside? Because look at that line. That line is going to die. It's very bad. The line must not die. Okay? The same for that one. Same here, same there. All the other lines are okay. Don't mind about the line here because I'm taking care of only of the inside. So what can I do? And same for this line here. So here, in that case, it's very simple because that line don't want to die, so she want to go this way. That line want to go this way. So they are meeting together, and both are alive. Okay? Same thing here. This line want to leave, and she's going to meet the symmetric. Now, here, this line want to leave. This one too, but they can meet directly. This one too, they met directly. So now we are getting a first pattern, and we are getting new tiles in shape of what kind of tiles? 1, 2, yes. This one, it's like dart. And that one, it looks like a moon, something like that. Je suis en train de faire. And now that shape, you know where it comes from. You have it on the paper. You can recognize it. Another skeleton. Very easy, can be first one. 1, 2, 3, 4, 5, 7, etc. It can be a square. So please everybody look at the board. So now you can draw that. It's a very simple skeleton too. Now you see some lines. This line is unhappy. Is going to die. So it wants to go somewhere. Turn to go somewhere, etc. So you have to solve that. Now, because we have few time left. Few time? 10 minutes. So I'm going to give you another tricky things. It's the way to work just with skeleton. An easy way, because if you just want to draw the structure of a big pattern, to draw the skeleton with all those lines can be a little bit boring and too much lines. So there is a simplest way to do, for you can draw very easily any skeleton in a simplified way. What I do for each a skeleton is made from star. For each star, I draw just one dot, and it made from a distance. There is a distance for this distance here. That distance, I draw like this. So just 1.5. For example, this skeleton, I draw it like this. This is for a star. 1.5 is for the shaft. Star, 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 star. And for the first one you did before, you do like that, 1.5, and here just 1. I would like this to be clear for anybody. Yeah?
I can't understand 1.5. Why it's 1.5? I can't
Why? Because it works perfectly.
Scale.
It works perfectly. It's like if I said, so this is 1.5, this is just the diagonal, is square of 2. It's the same approximation. It's a basis approximation of square 2 by 1.5, which is not so good, but can work perfectly for what we have to do with. So now, if this is clear, after you are doing that, I want you to draw a skeleton, this skeleton. But one diagonal, 1.5 square, one diagonal, 1.5 square, one diagonal. Okay. So I would like that this to be clear for everybody. So I want you to draw the real skeleton. Means that this, for example, this point, I have to translate this point into that. I have to translate this one, that one, into the second one, which is 1, 2, 3, 4, 5, 6, 7 here. So this is the translation of that part. And the translation of that part will be something like that. So you can understand that what I am drawing here, it's an octagonal skeleton, very simple. So now what I want you to do it's just to draw a solution for this skeleton and to draw that. Because if you get that way to draw the skeleton in a very simplified way, so you are good enough to go ahead and do very complex things. Yeah? Excuse me, that's the end, and I finished. Just one to finish. Everybody, please. That's the end of the workshop, everybody. Now, I want to ask you a question. Do you like symmetry?
Yes.
Yeah. No? You don't like? I don't like. No. Most people answer, no, I don't like symmetry. But some people answer, yes, I like symmetry. But why do I like symmetry? I like symmetry because I like to break symmetry. Okay? That's the end, thank you.